Cool. Hi everyone. I'm a little bit nervous. My name is Sarah Lee, and I'm a PhD from UIST. And today I'm going to present our research SERENUS, a new approach to alleviate low battery anxiety through real-time, accurate, and user-friendly energy consumption prediction of mobile applications. And this is a joint work with my co-authors, Dae-Ryong Jang and Junyoung Choi, Jeon Kwak, Seoyun Son, Jin Song, and In-Sik Shin. Today, many of us experience what we call low battery anxiety, a sense of worry or discomfort when our mobile devices are running out of battery. In these days, since mobile devices are so essential in our daily lives, so I think low battery anxiety stems from the fear of not being able to those kind of critical applications such as payment and banking or navigation or making call when the battery is low. According to LG's research report, the quality of experience of applications drops by 90% when the battery is under 20%. It's quite huge, isn't it? So, our goal is to alleviate low battery anxiety. But how? How can you achieve this goal? Before to do this, we have to figure out following questions. What they feel, why they feel anxiety, and what is the root cause of this anxiety. In psychology, it's well known that anxiety stems from uncertainty. So we assume that low battery anxiety follows the same patterns. Users feel anxiety because they are uncertain about how much battery life remains and whether it will be enough for their future needs. So, we can help users reduce this uncertainty. We might be able to alleviate their anxiety. With SERENUS, our goal is simple. We want to provide users with the information they need to manage their battery more efficiently. Our system SERENUS offers accurate, real-time prediction of mobile application energy consumption in a user-friendly way. It does this right before the user decides whether to use an application or not. This way, users can make informed choices and make a decision about considering their battery usage based on reliable predictions. Our system is useful in a variety of contexts. For example, users can see how much battery streaming videos will consume in details like that. With this information, they can decide whether to proceed or adjust their behavior to conserve the battery. There are another cases like Navigating app as well. SERENUS operates entirely within user's device and follows 3 key steps. First, it collects data about the hardware resources being used by the target applications. Second, it constructs their own power model based on collected energy consumption of each hardware components. And finally, it provides real-time energy consumption predictions, then enabling users to better manage their battery life. It looks quite so simple because we have to simplify the workflow because of time limits. So if you know or wonder how it works in detail, please read my paper. We also conducted a user study with 2 different conditions, one using an existing system Android and one using SERENUS, and a field study during 1 week of using SERENUS. We also quantified our target metric as follows. To measure the degree of anxiety, we surveyed stage 6 test when the user faced the lower battery anxiety during user studies, and conducted content analysis on the answers of post-survey. And for the degree of planning their application usage, we conducted a survey using a 7-point Likert scale about the application usage-related questions. Then we compare these quantified metrics between base group and system group. We observed that SERENUS shows a 40% reduction in anxiety rather than the base group, and a 27% improvement in application usability when the battery is low. Additionally, our system scored 77 out of 100 on the system usability score, and also achieve about 90% accuracy in predicting energy consumption across 4 different device models and 12 well-known real-world open source applications. Our finding shows that low battery anxiety is primarily driven by uncertainty in 3 categories. Users are unsure whether their remaining battery will last for the application they need, and this uncertainty is highlighted by unexpected events, such as receiving a sudden call or needing to use an application unexpectedly. And these kind of unpredictable situations create the core anxiety users face when their battery is low. In conclusion, SERENUS successfully alleviates low battery anxiety by providing accurate, real-time, and user-friendly energy consumption predictions. And by reducing the uncertainty around battery usage, users can feel more confidence in managing their mobile devices. And thank you for your attention. Are there any questions? Feel free to reach out to me via email. Thank you.
Insok from Postec. Great work. My question is that I found it very novel to approach the low battery issue from the user perspective of the anxiety. And then my curiosity is that your experiment Did you evaluate the system over some long-term usage where the user can actually perceive the possible inaccuracy of your prediction model? The reason for asking this question is that the user might, the system might lower the user's anxiety with the short-term prediction, where the user might not necessarily be able to perceive the possible inaccuracy. But over time, the user might discover that, oh, the prediction is not as accurate as I expected, and then it might actually aggravate the uncertainty of the user.
Yeah, that's right. The accuracy impact on users' expectation of the system. So we also conduct the different accuracy, same experiments on different accuracy, and usually we figure out the acceptable accuracy the user believe the system. It's about 35%. So our system is around 60% accuracy. So user, I think user believe our system.
Thank you. We can talk more offline.
Okay, cool.
Hello, thank you for the talk. I'm a master's student from CMU, and I was curious of levels of implementation for electric cars, because it's very similar idea for a dashboard, like apps, battery level, and everything. I was curious of your thoughts on the implementation. Could you maybe elaborate a little more on how that might happen or could happen?
How to implement this system?
Yeah.
Do you know the battery stat in AOSP?
Sorry?
Do you know this system service battery stats in AOSP?
Not quite.
It's already implemented in the well-known Android OS, and it tracks the hardware resource usage in runtime. We follow this technique to track the data, collect to train data. Am I understanding your question?
I'm just like processing what you're saying.
I'm sorry.
Maybe I'll ask you more after.
Sure. I'll wait you. Waiting for you.